So we have a polynomial on the board. I want to evaluate it at x equals 2. So what I have to do is I'm going to replace every x with 2. Once I've done that, I just need to simplify. So 2 cubed is 8 times 3 is 24. 2 squared is 4 times 4 is 16. 2 times negative 2 is negative 4 plus 3. So 24 plus 16 is 40. 40 minus 4 is 36. 36 plus 3, 39. Okay? Not too bad. Plug it in and evaluate. Or if we use our synthetic division, watch what happens. If I drop the 3, 2 times 3 is 6. 6 plus 4 is 10. 2 times 10 is 20. 20 minus 2 is 18. 18 times 2 is 36. 36 plus 3 is 39. Same solution. Okay? Synthetic division, pretty quick. This is called the remainder theorem. Your remainder is your y value. Okay? So I plug in 2 to my function, I get out 39. If I do my division, I'm dividing this 2 into my polynomial, and I get 39. Your remainder is equivalent to your y value. That's the remainder theorem. So your remainder is equal to the y value at the given x value. Remainder theorem. Remainder equals y value. The reason that is important is we're going to be moving forward and we're going to be solving polynomials. When we solve a polynomial, we want to know when our graph or our function crosses the x-axis. The x-axis is where y equals 0. So when my remainder is 0, we have a factor. When I have a remainder other than 0, that's the y value, and the y value is not 0, so it's not a factor. Okay? So what we've done here is with my polynomial, I've just shown that x minus 2 is not a factor of my polynomial. All right, so let's take a real quick look at a short example to prove that is true. So if we have x squared minus 5x minus 14, I want to know, is x plus 2 a factor? Okay? Is x plus 2 a factor? So I'm going to put in negative 2 into my box, then 1, minus 5, and minus 14. I'm going to drop the 1. 1 times negative 2 is negative 2. Negative 5 and negative 2, that's negative 7. Negative 7 times negative 2 is a positive 14, and I get a 0. Okay? If the remainder is 0, that means I have a factor. So is x plus 2 a factor? Yes, it is. Once we divide, right now we're left with x minus 7. X minus 7 is also a factor of my x squared minus 5x minus 14. So if we were to take those, x plus 2, and times it by x minus 7, it's going to take us back to our original quadratic. Okay, so this is the factor theorem. If the remainder is 0, then yes, you have a factor. Okay. As we move forward, our goal is to find our factors, so we've got to know, is it a factor or isn't it? If we have a remainder of 0, it is a factor.